Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, it's been a long time since I've given you a random topic on long video format discussion. So my topic for this evening will be a long video format. This is a random topic. This is an additional topic for the long video format. So I will be placing this random topic on my mix random topics. Okay. So it will not be added to the specified long video format topic like an algebra maybe. So I will be placing this one on my mixed topics, random topics. Okay. The subject matter for tonight will be regarding the study of the so-called logarithms. We've been solving problems involving logarithms, but most of the time, the base of the logarithm are actually the same all throughout the given equation. Okay, so for tonight, I will be presenting a problem in which the base of the logarithm that is placed on the equation, the given equation, are not actually the same. Okay, let's proceed. We are given a problem here. What is the real value of small letter a in the equation? Okay, we are given the equation. It's a logarithmic equation. We could not even say that this is a common logarithm or this should be a natural logarithm. It is just that the base of the logarithm that is given are not actually the same. So the important thing here is that we will be presenting our solution and how to attack a problem if the base of the logarithm on the given equation are not the same. Okay, the given logarithmic equation is the logarithm of 54 with the base of 3 minus the logarithm of 6 again with the base of 3. So as you can see, the base of the left hand side logarithm are actually 3. And this should be equal to the logarithm of a, small letter a, the one we are looking for, if the base is 6. So the problem here is what will be a equal to. Okay, let's try to attack the proper concept and how to attack this problem. Solution. I always present solution like this. So it seems I'm always on the board exam. So I'm actually a board-oriented engineer or creator maybe. I always present my solution like this, okay? Whether it's a long video format or short form videos, it's always the same. Okay, let's try to bring out the solution. I will be rewriting the given logarithmic equation, so the logarithm of 54 with the base of 3 minus the logarithm of 6 with the base of 3, and this should be equal to the logarithm of a with the base of 6. So this is 3, this is 3, and this is 6. So it falls under the so-called logarithm of an equation in which the bases are actually different. Okay, let's try to attack the solution of this problem here. For the left-hand side, we can do something. Actually, we will be rewriting this one under the form. Their bases are actually the same, right? So the logarithm of a difference under the study of logarithm, whether common logarithm or natural logarithm, it's actually the logarithm of a difference is actually a logarithm of equation as long as the base is the same. So the left hand side can be written as the logarithm of the first one all over the logarithm of the second one, which is negative, because the logarithm of a difference is actually the logarithm of a quotient. Okay, so this one can be written as the logarithm of the ratio 54 over 6 with the same base 3, and this should be equal to. So actually, we simplify the left hand side. We can do something on the left hand side. right? And this should be equal to the logarithm of a with the base of 6. What is 54 over 6? That's 9, right? That's 9. So what will come out on the left-hand side will be the logarithm of 9, which emanates from the ratio 54 over 6. The base is 3, and this should be equal to the logarithm of a with the base of 6. But what is the logarithm of 9 with the base of 3? The logarithm of 9 with the base of 3 is actually equal to 2. Okay? Well, you don't have to use your calculator. Because if we try to define a logarithm, okay, it is the power to which the base of the logarithm must be raised to equal that given number. Oh, that's the definition of a logarithm. So from that alone, I don't have to use my calculator. The number, okay, in which the base must be raised to equal this number is actually 2. Because 3 square is actually 9. So the logarithm of 9 with the base of 3 should be equal to 2. I don't have to use my calculator regarding that one. I just presented the definition of logarithm. It is the power to which the base of the logarithm must be raised to equal that number. So the logarithm of 9 with the base of 3 should be equal to 2 because 3 square is actually 9. So the logarithm of 9 with the base of 3 should be equal to 2. And this should be equal to the logarithm of a with the base of 6. Luckily, we eliminated the logarithm thing on the left-hand side. Okay? No more logarithm on the left-hand side. Okay? Because we simplify it by using our definition of the logarithm of a quotient and the definition of a logarithm. Okay? Take the antilog of both sides. To solve for a here, without this logarithm thing, we must have to take the reciprocal of a logarithm, and the reciprocal of a logarithm is actually the antilog. Okay? And the proper way on how to take the antilog, take note of the base of the logarithm on the right, it is 6, right? So when we say we take the antilog, we will take that base, then we raise that for both the value of the left-hand side and right-hand side. So since the base of this logarithm is 6, I will place here 6 square, okay, and this should be equal to 6 raised to the logarithm of a with the base of 6. And the meaning of this is actually antilog of a. Antilog of a. Right? That's the proper way on how to take the antilog of the logarithm of a with the base of 6. We will take the base, then we raise that to the given logarithm. But for the left-hand side, we can take 6, and the only value that remains on the left-hand side is 2, so it will become 6 square. Okay, and what is 6 square? We could do that value mentally, it will be 36. And the antilog of the logarithm of a is just a. Okay, so rearranging this one, a now will be equal to 36. Okay, that's it, guys. That's the way how to solve a problem involving an equation in which the base of the logarithm that is involved are actually different. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.